Children, let us understand the fourth chapter, Carbon and its Compounds, in which we are going to concentrate on the versatile nature of carbon and covalent bonds. Carbon is such a unique element that it forms a large number of compounds, despite of being in very less concentration on Earth's atmosphere and Earth's crust. Because of the large number of compounds that it forms, its importance is so much that a different branch of chemistry is devoted to it, known as organic chemistry, which is now called as carbon chemistry. There was a vital force theory which was given by Berzelius, which states that carbon compounds can be synthesized by living organisms only. Carbon compounds cannot be synthesized in laboratory. But this theory was discarded by a scientist named as Wöhler. He synthesized urea using ammonium cyanate in the laboratory. Ammonium cyanate, when it is heated, then urea was produced in the laboratory, and thus the vital force theory was discarded. Allotropy is the property of some elements, including carbon, in which one element exists in different physical forms. For example, if we consider sulfur, then sulfur exists in two allotropic forms, that is rhombic sulfur and monoclinic sulfur. Similarly, if we consider carbon, then carbon exists in different physical forms like graphite and diamond. Then carbon also exists in the form of coal, and there is a synthetic physical form also known as fullerene. These are the allotropes of carbon: graphite, diamond, and fullerene. Let us now understand the characteristics of these allotropes one by one. If we consider graphite, then graphite has a hexagonal layered structure in which the layers are binded to each other by very weak van der Waals forces. And because of this layered structure, it is slippery. Every carbon is bonded to 3 other carbon atoms. Thus, 1 electron is free on every carbon atom. Because of this, graphite is a good conductor of electricity, and thus it is used to make electrodes. Because of the layered structure, which are binded to each other by weak van der Waals forces, it is slippery in nature. Thus, it is used as a dry lubricant, and it is used in those parts of the machines where oiling cannot be done. It is also used as lead in the pencils, again because of the slippery nature. As we put pressure on the pencil lead, the pencil starts writing or leaving a mark on the paper. Diamond has a tetrahedral structure, because of which it has a compact structure. Every carbon is bonded to 4 other carbon atoms in it, and because of its compact nature, it is one of the hardest substances in the world. It is used to make jewelry. Black diamond is used in drilling machines. It is used to cut and polish other diamonds. Fullerene, which are also known as buckyballs. The name fullerene comes from the name of an architect whose architectural structures resemble the structure of fullerene. Thus, It is also sometimes known as Buckminster fullerene. The carbon atoms, they are arranged in the form of hexagons and pentagons, which are connected to each other to form football-like structure. These are the structures of graphite, diamond, and fullerene. Carbon forms covalent bond. It has got 4 electrons in its outermost shell, so it needs 4 more electrons. To complete its octet, carbon shares its electrons with other elements. It does not have a tendency to lose or gain 4 electrons. If it gains 4 electrons, in this case 6 protons will not be able to hold 10 electrons. Loss of 4 electrons is very difficult due to energy consideration. Moreover, 6 protons holding 2 electrons, that is also not possible. Thus, carbon neither gain electrons nor lose electrons. Instead, carbon share electrons with other elements and thus complete its octet. And sharing of electrons means a covalent bond is formed. Because of its valency equal to 4, carbon forms different types of compounds. Because of its small atomic radius, the bonds which carbon forms, that is strong. One more property carbon shows, which is called catenation, which means carbon has got the tendency to form long chains. And thus, carbon has got a versatile nature, forming large number of molecules. Let's see the covalent bond formation of different molecules. Hydrogen, it forms the covalent bond in this way, and it is written like this. Oxygen. The electronic configuration of oxygen atom is 2,6. It means it needs 2 more electrons. So, oxygen, the covalent bond in oxygen is written in this way, the double bond. See, there are 4 electrons here. So, O double bond O. Nitrogen. The electronic configuration of nitrogen is 2,5. Thus, it needs 3 more electrons to complete its octet. So, we are going to write the structure in this way. 3 electrons here, 3 electrons here, and 2 electrons like this. The electron dot structure is like this. It means there are 3 pairs of electrons being shared between 2 nitrogen atoms, and thus there is a triple bond formed between 2 nitrogens. Now let's see how covalent bonds are formed in case of ammonia. This is how nitrogen has got 5 electrons, 1, 2, 3, 4, 5. Hydrogen has got 1 electrons, and now all these electrons, they are shared between nitrogen and hydrogen. The structure is written in this way. Let's see the covalent bond formation of water. Oxygen, hydrogen, hydrogen. This is how the bonds are formed between hydrogen and oxygen. 1 bond here, 1 bond here. So, when the structure of water is written, then it is written in this way. These are the lone pair of electrons. which are present on oxygen. The covalent bond formation in case of methane is like this: carbon having 4 electrons, hydrogen, and this is how the structure looks like. Then methane, carbon dioxide. So there is a double bond. One bond here, one bond here, one here, one here. So the structure of carbon dioxide is like this. I hope you must have understood the covalent bond formation and the allotropic forms of carbon.